Hi, everyone. Today I'm going to be talking about a project that was very recently funded through the Secure Blockchain Initiative, so I'd like to thank the program and all the sponsors. So because this is a very new project, we don't really have a lot by way of results yet, so I'll tell you a little bit about the problem formulation and kind of some initial thoughts. So this project is about the incentive mechanisms that incentivize liquidity providers in AMMs, and how your choice of incentive mechanism can either incentivize or disincentivize liquidity providers. So most of you know this, automated market makers are decentralized trading markets where the price of trades is automatically determined, unlike limit order books like traditional finance. So these AMMs have a couple of different components. One is the liquidity pool. So we can think of this as like a swimming pool where people are going to input different amounts of different currencies. So for this talk, I'm going to assume that there are only two assets in this liquidity pool. So for example, maybe one is Bitcoin and one is USDC, and individuals can trade one for the other. The second key ingredient is liquidity providers. So these are people who are depositing funds into the pool, and they can deposit different amounts into the pool, and they are doing this as kind of an investment. And we'll talk in just a minute about why it's an investment. The third ingredient is some kind of automated formula for deciding the trading price. Okay, so the main difference between AMMs and traditional trading markets is that the prices are automatically determined. So most AMMs are structured as constant function market makers. So here you can see an example of a price curve. Okay. All right, so I'm not going to be too worried about the actual mechanism, or about the price mechanism for AMMs. I'm more interested in trying to understand why liquidity providers actually provide liquidity. So why do they invest? As I mentioned earlier, it's a kind of investment for them. So when a user inputs a transaction to the system and tries to trade one asset for another, so for example, let's suppose we have this transaction that is trying to buy USDC with Bitcoin. Some portion of that transaction is kept aside as a fee, okay? And that fee gets added to the pool. And when a liquidity provider withdraws their liquidity, they get allocated some portion of the reserves in this pool. It's like a reward for them. So these fees are essentially paying the liquidity providers for providing liquidity. Now, in Uniswap V1 and V2, which are decentralized exchanges that are running on Ethereum, so some of the most common, one of the most common ones, Uniswap is, these fees are split proportionally among liquidity providers. Okay, so if all of the liquidity providers input funds equally, then they'll get to equally divide the returns. However, more recently, Uniswap 3 introduced a new incentive mechanism called concentrated liquidity. Okay? And the idea here was that we would split our pool into different price ranges. Okay? So here, instead of just having one pool of Bitcoin and one pool of USDC, we now have three different price ranges. And each price range is going to get a different amount of liquidity from the liquidity providers. So basically, they can choose which price ranges they want to invest in. And the intuition here is that when the price moves outside your liquidity range, you don't lose. Okay? So one of the problems with the previous method, let me see if I can pull that up. One of the problems with this mechanism in Uniswap V1 and V2 is that if the price changes substantially, investors can actually lose a lot of money. So this concentrated liquidity mechanism is trying to counter that by limiting your losses to the price range that you have invested in. So for example, now when a transaction is submitted to the system, we take the current price, and the transaction fee gets added to the pool that is associated with that current price. And your liquidity is only used in the price ranges where you deposited liquidity. And correspondingly, you don't lose as much, or you don't lose if the price moves outside of your liquidity range. So a natural question to ask is, which of these two incentive mechanisms should we be using? Okay, so there's some intuitive arguments in the Uniswap V3 white paper that is arguing that concentrated liquidity is a good idea, but we don't actually know quantitatively if that's the case. And in particular, there's been some prior work analyzing how liquidity providers should behave, mainly in Uniswap V2. And they've come up with some conclusions like if the price is very volatile, liquidity providers are actually not incentivized to invest. However, a lot of the theoretical analysis of these incentive mechanisms don't seem to match empirical observations. We had a nice talk on loss versus rebalancing yesterday, which is kind of related, but is a slightly different aspect of this problem. So in this project, we wanted to ask if there are multiple competing LPs or liquidity providers, is there a globally optimal investment strategy? And if so, which incentive mechanism provides greater utility both to liquidity providers and which incentive mechanism encourages greater investment overall, so encourages system health in some sense. And based on these insights, we would like to try to understand, is there a better design for these incentive mechanisms? So we've seen two examples here, one for Uniswap V2 and one for Uniswap V3, but maybe there's something better altogether. So in our initial formulation, we came up with a very simple model where we look at some set of price ranges and LPs, and each price range has some profit, rho m, and the price fluctuates randomly with a stationary distribution pi. And we'll denote by L sub mi the liquidity provided by the ith liquidity provider in the price range m. And we model the utility of each liquidity provider as essentially an average over this distribution. So here, this red ratio is the ratio of rewards to agent I in the price range m, or in that pool m. And it's weighted according to the probability of being in that price range and the reward that you get from that price range. So our initial question, like very basic starting point, is what is the Nash equilibrium for this game? And we can analyze it using some techniques like Rosen's classical strict concavity condition, diagonal strict concavity. Then we can try to think about this for a slightly more complex family of reward mechanisms. So in particular, in this formulation, we're going to add this parameter beta, which is weighting how much to pay each liquidity provider. So here you can see the LMIs, or the investments from each liquidity provider, is raised to the beta power. So intuitively, when beta equals 0, this means that we're splitting rewards evenly among all LPs in a range. So this is like the communist solution. On the other hand, when beta equals infinity, we only reward the largest provider. So this is like the winner-takes-all solution. And right now, Uniswap V3 is setting beta equal to 1, essentially. So what we want to do is to be able to analyze this family of incentive mechanisms and try to understand, is there a best point that encourages the most investment and gives the best reward to providers? All right, so to summarize, different incentive mechanisms affect LPs' willingness to invest. And in fact, we've seen that in Uniswap V3, there seems to be less investment than previously. We don't currently theoretically understand the effects of competition among different LPs. And so the goal of this project is to study in this multi-agent setting how incentive mechanisms affect AMMs and LPs' willingness to invest. And I want to give a shout out to my collaborators, in particular Wei Zhao Tang, who's my PhD student and is about to graduate, and shameless plug, is also looking for industry jobs. And my other colleague, Rashid El Azouzi, who's visiting from the University of Avignon. He's also awesome, but is not looking for jobs, as far as I know. Thank you all.
Hi, thank you for the very interesting talk. When you're talking about Uniswap V3s and different market pools existing, you mentioned that there's a floor on how much you can lose, but is there also a ceiling on how much you can gain? That is, by putting a ceiling there, are you artificially incentivizing people to pull money out and then put it back in to be put into a price range that's further higher up?
Potentially, yeah. If you have information about, so yes. It limits how much you can lose and also how much you can gain. So potentially it could incentivize that kind of behavior. There is some friction in the sense that every time you withdraw, you incur transaction fees and also like time delay. But yeah.
Thank you.
Thanks.
Thank Giulia.